You will have noticed from the graph above of y equals log to the base 2 of x that the shape is like this. The graph of y equals log to the base 0.5 or a half of x had a shape as shown below. One graph is a reflection in the x-axis of the other, and this should not surprise us, as if we consider log to the base 0.5 of x, we can use change of base to make that log to the base 2 of x over log to the base 2 of 0.5, which is log to the base 2 of x over log to the base 2 of 2 to the negative 1, or a half. Using a log law, that's log to the base 2 of x over negative log to the base 2 of 2, and of course log to the base 2 of 2 is 1. So this is negative log to the base 2 of x, and hence we can see why it's a reflection in the x-axis. In general, the graph of y equals log to the base a of x is shaped like y equals log to the base 2 of x if a is greater than 1, and shaped like y equals log to the base 0.5 of x if a is between 0 and 1. And as we've mentioned before, logs do not have negative bases. The logarithmic function y equals log to the base a of x is the inverse function of the exponential function y equals a to the x. Therefore, the graph of y equals log to the base a of x is the reflection of y equals a to the x in the line y equals x. If a is greater than 1, then we get a picture like this. This is the line y equals x. This is y equals log to the base a of x. And this is y equals a to the x. And we can clearly see that there's a reflection across y equals x as the mirror line. If a is between 0 and 1, the picture looks more like this. Y equals x again. This one is the logarithm. And this one here is the exponential. But remember now, a is between 0 and 1. So it's a fraction like 0.6, say. We should note that 1, 0 is the x-intercept of the logarithm. And 0, 1, of course, is the y-intercept of the exponential. This is a fact that you should know. The essential features of the log graph that we need to be aware of when doing graph transformations are: the vertical asymptote is the y-axis. Now that's the negative y-axis if a is greater than 1, and the positive y-axis if a is between 0 and 1. And we can see that over here, that the positive y-axis is the asymptote. And this, remember, was the case when a was between 0 and 1. The x-intercept is at 1, 0 in both cases. The only transformations we need to know about in this course are y equals log to the base a of x plus b, and y equals log to the base a of x take away c. Note the difference with the plus b outside and the minus c inside. We should know that the top one, this one here, is a vertical translation, which will shift the axis intercept, but not the asymptote. We should be able to find the exact value of the new x-intercept, although we may not always be expected to do so. The bottom one is a horizontal translation, c units to the right. This will move the vertical asymptote and move the x-intercept c units to the right as well.